Unlike the median, a mean or an average does not take the distribution of the data points into account. The presence of extreme data points, we call them outliers in statistics, can distort the means. For instance, if we add Bill Gates or Steve Jobs' income to our existing income data, we are going to blow up the average or mean income data, right? Means are appropriate measures of central tendency when the variable has very specific and unique values like weight, height, income, age, the length of hospital stay, temperature, and so on. In this case, it is almost impossible to use the mode on variables like this because almost every individual has a unique value. Means can also be used when there are no individuals with extreme values. The data is not skewed. The data is normally distributed. Unlike the mean, the median takes the distribution of the data points into account. Medians are essentially the 50th percentile. The median appears best to represent the center of the data. It is essentially the midpoint value that separates the data points into two halves. Because medians are not affected by extreme values in the dataset, they are more meaningful and stable than means as measures of central tendency. It's more intuitive to use the median if Bill Gates and Steve Jobs or any billionaire's income are in our dataset. If we use the median, we just have to take the midpoint and report on it. Medians are appropriate measures of central tendency when the variable has very specific and unique values like weight, height, income, age, the length of hospital stay, temperature, and so on. In this case, it is almost impossible to use the mode on variables like this because almost every individual has a unique value. Medians are also used when individuals has extreme values in our dataset. They are either extremely rich or extremely poor. They are either very tall or very short. They are either very thin or obese. Medians can also be used when the data is skewed. Medians are also appropriate when the data is not normally distributed or the distribution of the data is uncertain. Medians are also appropriate when we are unsure about how the data is distributed or when we have any non-parametric type of data. In other words, medians can be used for both parametric and non-parametric data. A mode is the value that appears most frequently in a dataset. The mode makes intuitive sense when the variable has few categories like sex, race, age, education, and so forth. The mode also makes intuitive sense when the variable takes a limited number of values. This often happens in Likert scale variables that ask people whether they strongly disagree, or are neutral, agree, or strongly agree on a particular stance. This is also used in variables that ask people to rate their health. For instance, we can assign the number 1 for poor health, the number 2 for fair health, the number 3 for good health, the number 4 for very good health, and the number 5 for excellent health. Mode can also be used in rating types questions. In this case, we can assign the number 1 for far from satisfactory, the number 2 for not satisfactory, the number 3 for somewhat satisfactory, and the number 4 for satisfactory. With variables that have few categories or take a limited number of values, the analyst can just calculate the number or frequency, or the percentage of people that fall under each category. When the variables has very few categories, it may not make sense to calculate the mean or median for these variables.